So, welcome back to Engine Shop Joe. And just when Engine Shop Joe thinks he's seen everything and he can pretty much figure out most of the stuff that he's got to deal with, Engine Shop Joe gets his you-know-what handed to him. And so did a lot of other people, by the way. So this is a good one. So this was an ISL 2150, and it was in a boom truck, and it was a customer's unit. So our tech, and this is in, I think it was down in the Carolinas somewhere. Our tech drives to the customer's yard. It's 100 miles one way, and he's got fault code 1242, which is throttle pod voltage has varied more than 2% from the other throttle pots voltage. So on this system, on the throttles, there's dual pots. Today there's dual pots that are Hall effect, and the older ones were dual pots that were just carbon wipers. So it was variable resistance instead of, it actually was voltage at the ECM, but if we measure the pedal, it's resistance, where the new ones, you've got voltage coming in and then voltage going out, and the Hall effect sensor takes care of adjusting the signal voltage instead of using resistance. So it's one pot, but there's two sections to it. It's got 6 wires on it. And you'll see how the voltage is fed a little later. But so we logged this fault. So our guy goes out, he gets the customer says, well, why don't you just get a new throttle pedal and put it in? So he buys a new throttle pedal, comes with the pots, the mechanical pedal. It comes with the harness, a short section of harness. He puts it in, bolts it all up. Hey, the world is good. Drives it around, it's okay. Customer drives it, it's okay. He gets in his truck and drives 100 miles home. Next week, customer using the truck, drives it around, calls up, hey, the red light's on, the engine only idles. We drive 100 miles back, same fault code, 1242. Again, that fault code is, as the throttle is being depressed, there's more than 2% difference between the signal voltages that the pots are sending to the ECM. So he calls me up and he goes, what do you think? And I go, well, maybe the signal wires have corrosion in them, one of them somewhere. I said, if I were you, because it's signal wire we're having problems with, and he measured the voltage and checked the ground at the plug-in for the pots, 5 volts and 5 volts and 2 good grounds. And the 5 volts is fed out of the ECM. They use 2 different 5 volt supplies. One feeds just pot 1 and the other one feeds pot 2 and a couple other sensors that for the most part aren't used too much. And we'll see what that is in a little bit. So he changes those wires. The world is good. He clears the faults, drives it, customer drives it. He drives 100 miles back to the shop. And a couple weeks later, we get a call, the red light's on it, it'll only idle, drive 100 miles to where the truck's at, and yes, fault code 1242 is active again. It's inactive, but there's multiple counts on it, and when it is active, the only way to get it to go inactive is a key cycle. So if the guy's driving down the freeway and it goes active, he's on the side of the road. So we go out, I tell him load test all the wiring. He load tests all the wiring for the throttle, and it all checks out okay. I tell him to disconnect everything and plug everything back in. Everything looks good. There's no corrosion. It seems okay. I said, well, maybe when you unplug something and plugged it in, you fixed the resistance we didn't know about, because we are talking about small voltages. I said, if that's not it, we got to replace the ECM. So the customer says, just get an ECM, because I'm tired of messing around with this. So we order an ECM, and we put it on a truck, and in about 2 weeks, we get a call, the red light's on, and we've got a problem with 1242. Throttle signal voltages differ more than 2%. So I have our guy start it up and run it and drive it around for a half an hour doing a data log. And I'm looking, and the 5-volt seems steady, but I do see signal voltages occasionally are, I'm going to call it a percent off or so. And I know the wiring is good, so I tell our guy, it looks like this ECM we got's got a problem. It shouldn't be doing this. So because it's an ECM and we were talking about changing it, I got to call Cummins and put in a help ticket. And I ended up going from tier 1 to tier 2 help. And then finally I got an old guy like me who was smarter than me in tier 3 help. And he's looking at this and he's thinking, and he goes, I ran into this a long time ago. And he goes, we could change the ECM and it might fix it, but it might not. And he says, I'm going to tell you what I want you to do, because he says, I'm pretty sure this will fix it. So this is what he had us do. Let's take a look. So first, this is a snapshot of the faults, and I also inserted the schematics. You could see that, and it's fault code 1242, and it drives the red light, and it will only idle when it happens, and it's accelerator pedal or lever position sensor 1. The data is erratic, intermittent, or incorrect, and again, it's that 2% thing. So on the right, you see fault code 1242. The engine control module detects the readings between accelerator position 1 and position sensor 2 differ by more than 2%. Now, we can see in the schematic, look at pin 27. That's the ECM plug, sensor supply number 4. It feeds only accelerator position number 1. Or pot number 1. And then pin 26, that's sensor supply 5, it feeds only accelerator position 2, but it also feeds the remote accelerator pedal lever. It also feeds the coolant level sensor. It also feeds an OEM pressure sensor that would be for a switch, say a hydraulic pressure or air pressure switch, that would tell the ECM to change states, and that would be a special calibration that used that switch. So anyway, we never had a problem with any faults for the 5-volt supply dropping too low. And the fault was always that the throttle signals didn't match. So I talked to that engineer about this, and then he talked to me about what caused it and what he thought it could be, and he said well, it's possible that the 5-volt supplies are changing. And he said, in other words, one might be 5.00 and the other one might go to 5.08. And he said that might be enough to drive the problem. So he said, I've seen that before. And he said, unfortunately, the throttle position is an extremely sensitive circuit, and everything has to line up just perfectly, or we'll have these problems. And he said, it's, that's all about safety of knowing where that pedal really is. So he said, this is what I want you to do. So he said, this is what I want you to do. I want you to cut the wire where it I want you to cut wire number 26, which is the 5-volt supply, to accelerator position sensor signal 2. And I want you to jump the 5-volt supply from pot 1 over to feed pot 2. And I've got a tan circle or orange circle around that thick red bar, which represents the wire we soldered in. And I had our guys solder that wire together, not butt connect it. And then we just capped off where we cut it, and we left sensor supply 5 feed all the rest of those circuits, but it no longer fed the accelerator. And in troubleshooting this, and before we got to this stage, I had our guy unhook the coolant level sensor, and we weren't using a remote accelerator in this case, and we weren't using the OEM pressure sensor, and that does go down to another device that we weren't using. And so we still logged the fault randomly with those disconnected. So I thought it was a bad ECM with the bad 5-volt supply. And the engineer that I talked to said that he had seen tolerances in the 5-volt supply that did affect the throttle supply, signal supply, because if you drop the supply voltage through a mechanical pot with a carbon wiper, you're going to drop the signal voltage. So we jumped that wire, actually soldered it, made it permanent, told the customer what we did. I asked the engineer if there'd be any trouble feeding both pots with one supply, because now if supply 4 failed, he had no throttle. And he said he didn't see a problem with that. We weren't drawing anywhere near the current limit of that supply. So he said there shouldn't be any problem. So that was almost 6 months ago, and the customer called us back a few months ago and said, I want you to come out and look at something else, another machine he had. And he goes, by the way, that boom truck with the L9 that had the throttle problems has been running like a champ. I got about 4,000 miles on it and no more problems. So whatever you guys did, you fixed it. So my hat's off to the tier 3 engineer that I talked to at Cummins, who gave me good advice. And sometimes you just can't beat experience, you know. And once again, I learn something every day. And I probably will until the day I retire. And once I retire, I'll learn different things. So life's all about learning. Thanks for joining me at Engine Shop Joe and going through this crazy one. But they're out there, and you can figure them out just like we did. Take care. See you next time. Don't forget to subscribe.